Good morning, class, and welcome to this lesson on Kinematics 11, the basics of 2D motion. Today we will be able to break down 2D motion into its components. So let's go over this. So far, up until this point, we've had kinematic equations, okay? We have, velocity equals delta x over delta t. We've had, acceleration equals delta v over delta t. We've even had some other kinematic equations that look like this or like this. Okay, so we have all these equations, right? And there's even more. But let's just say these are all of our equations. But so far, all of these equations have assumed that an object was traveling on a straight line. It could be a straight line up, it could be a straight line down, or a straight line to the left, or to the right, or the left, but everything has been in a straight line. So this is what we call one-dimensional motion. It is one dimension. It is the x-axis or it is the y-axis, but it is not both. So right now, we're going to go over the basics of 2D motion, or the motion in two dimensions, okay? So most objects don't just travel in a straight line. A lot of objects travel in both 2D and not 3D. But for the purpose of this course is we're going to go over 2D. Okay. So sorry about that. So here we go. Let's look at it like let's look at a plane. Okay. Let's look at a plane. Okay. This is a fighter jet or something I got out of the book here. So a plane can travel horizontally, so it can travel in the x direction. A plane can travel vertically. It can travel in the y direction. At least this plane can. So what if it traveled in both the x direction and the y direction at the same time? If we look at this velocity vector here, the one in the y, and this velocity vector here, the one in the x, and put them together, this plane would travel at an angle. It would travel at an angle because it has an x component and a y component. So the resultant vector, this should sound familiar, the resultant vector of its velocity would be a combination of these two. So if this velocity right here has both an x component and a y component, okay? So here's another picture just to make it simple. It's traveling in both the x and the y direction at the same time. It's traveling in both the x direction and the y direction at the same time. So if it's traveling in both those at the same time, we have to start breaking up our equations. So let's take our equation, our kinematic equations. So if we have an equation like this, v equals v naught plus at. This is a classic kinematic equation. Many of us seen it already. Let's break that down even further. We have to look at the velocity in the x direction, the initial velocity in the x direction, and the acceleration in the x direction. X equals 1/2 v naught plus v times t. We have to look at the velocity in the x direction and the velocity in the x direction here. Whereas on the flip side, we can look at the velocity in the y direction here and there, or y equals 1/2 voy plus vy t. So look at these equations are the same equations. These equations are exactly the same. These equations are things that we have used a lot already. But the difference is, given the situation, we might have to take the velocity here. We might have to take any component here and say, hey, we need to look at it only in the x direction. Let's say I said this plane is flying with a velocity. This plane is flying with a velocity of I don't know, 50 meters per second in this direction right here. How long will it take to go? How long will it take to go? And we'll say it's flying at 20 degrees above the horizontal. How long will it take to go 200 meters up? 200 meters up. So I want to know long it's going to take to go 200 meters. T equals what? Okay, so I need to look at this and say it's going upward. It's not going 50 meters per second up, it's going 50 meters per second at a 20-degree angle. So I would have to find out what this vector is. All I need to find out, and this would be equal to the sine of 20 times 50. Okay, the sine of 20 times 50, and that would equal my velocity in the y direction. So my velocity in the y direction would equal the sine of 20 times 50. And so if I was doing my kinematic equations, velocity equals the change in x over the change in t, or in this case, velocity equals the change in y over the change in t, I would plug in velocity equals the sine of 20 times 50 meters per second equals, we want to go 200 meters up over delta t. Solve for t. Okay, so that is a simple situation in which we have to look at motion in 2 dimensions. We have to break it down into its parts and then look at the x direction, then look at the y direction, or look at the y direction and then look at the x direction to be able to solve what we're looking for. So it's all the same kinematic equations. It's the same equations, but they're just broken down. Okay, and so what I'm going to do in future videos here is I'm going to start making a lot more. I'm going to do just a bunch of example problems to help cement this idea in.